Hello, my name is Mr. Wyrick, and I'm here today to talk to you about Lesson 7.6. This will be the next to last lesson from Chapter 7, and it's talking about similarity transformation. Now, when we had the congruence transformations, we had reflection because everything would still be the exact same size. It's just reflected across a line. We had translation, which is to move it from one spot to another, and we had rotation. So we rotate around some kind of center point, but all of those were congruence transformations. They retain the exact same size and shape. So everything is the same about them. It's just you got to figure out where it is now. There's only one similarity transformation, and it's dilation. So you're making something larger, you're making something smaller, but it's retaining the exact same shape. So when we're talking about dilation, and this is stuff that you'll need to make sure that you have down in your notes, these definitions. The dilation means we are going to enlarge something or shrink something. If you've ever been to the eye doctor, when they dilate your pupils, they really make them huge. They make a chemical that makes everything in your eye think it's dark, so those get really big. There's still a circle, so that circle is dilated. It's made much larger, but it is still a circular shape. The similarity transformation, again, the definition here, same shape, different size, and it has to be similar. The center of dilation is a fixed point around which we do the dilation. There's a couple different ways you can use it. It's typically the origin. If you're going to use the Cartesian coordinates, nobody's really sadistic enough to make it anything else. It would be a lot more difficult to work, so they work from the origin. So on this one I have a couple of different right triangles. So if this one had a point on 1, 1 and was going out this way, then when we dilated it to make it larger, we would extend those sides out. It would be proportional, it would be similar. But say we multiplied everything by 3, this would now be at 3, 3. The other way that you'll see that center of dilation is if we have a square that's a round or some kind of shape that encompasses that origin, then the larger shape will also encompass that origin. It gets bigger in every direction, the exact same amount at the same time. Now the amount that it gets larger is that scale factor. Now I simplified their definition, you might want their definition too, but my simplified one is the number we multiply by. It's the K value. So this is what we took our smaller shape, our smaller similar shape, and we multiplied it by, or our first shape, maybe our larger one. Whichever one is designated as the shape that we had first. The K value is the number we multiply it by, and that'll make it either larger or smaller depending on what it is, which I put those down here. If it's enlargement, the K value is larger than 1. So if we're going from this tiny triangle to this larger triangle, we multiply by something greater than 1. It'd be we multiply by 2, we multiply by 5, we multiply by 3.1, we multiply by 5/4. Anything that's going to be larger than 1, even something like 1.0001, it would be noticeably larger. Okay? Then our reduction in this case is going to be a K value of less than 1. So that would be going from the larger triangle down to the smaller one, the larger square down to the smaller square. If we're multiplying by 2/3, if we're multiplying by 0.3, if we're multiplying by 1/4, a 16th, it's usually a fractional value. Sometimes it's a decimal. Either one is probably acceptable. You're going to see the fraction more often because it's easier to make a comparison that way, and it's easier to think that way about most of the stuff we've been doing up to this point in this chapter. Most of what you're going to be doing today is determining these scale factors. So what did we multiply by to get from one to the other? Direction is going to be huge. If you're seeing these on the Cartesian coordinates, they'll have one listed as A, B, C, and another one listed as A prime, B prime, and C prime to indicate what order they went in. We went from the smaller one to the larger one in this case because we see that prime value, that apostrophe with those letters. So make sure you're paying attention to that. Again, just like the last lesson, I've seen a lot of people not look at videos. So the only way you're going to get to know the numbers that we're working on is by watching this one. We're going to do all of the ones that are not the guided practice today. So numbers 6 through 27. And if you have questions on them, you can't figure out what's going on, just remember when you come into class and ask those questions. We'll see you there.